Hi everyone, how are you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy where every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is the series that I host for class 11 students, and the topic that we are discussing right now is gravitation. And this is lecture number 5 of gravitation, and today we'll be talking about escape velocity. Okay, so before I move ahead with today's discussion, let me introduce myself for those of you who don't know me yet. So, my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the JEE Mains and advanced examinations. And all this teaching so far had been offline. Now, offline, I have been associated with some of the topmost institutes that are there in the industry, JEE coaching industry, that is. As a student, I myself was All India rank 447 and All India rank 182, the two stages of the IIT exam that I gave. Yes, Shivam, today you are right on time. Okay, so yes, good to see you here. All right. So I also qualified NTSC Stage 2 as a student and I was in the top 1% in the NACP. I've already coached many students to top ranks in the IIT mains and advanced examinations in my offline setups. And now I hope to continue doing that here online with you guys. Now, as I said before this year, all my teaching had been offline and I had to move online. Okay, in this new situation, in this new arena, all of us have been forced to adapt. So that is one great way of adapting for students is by getting yourself the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators. You also have live polls and leaderboards in these classrooms, and you have test citizen analysis sessions. So all these features will make sure that your studies are going very smoothly even in this lockdown period. Now you also have live doubt clearing sessions, so that's a wonderful feature. Okay, so that is something only Unacademy Plus courses are offering. So after every 3 teaching sessions, you have an entire session dedicated to doubts. Okay, so where students can ask their doubts, all their doubts related to concepts or problem solving or anything that they are lagging with. So that will ensure that your doubts do not pile up. So I think with all these wonderful features and on top of these, you have the chance now to study from the topmost educators or from all across the nation from the comfort and safety of your home. So Unacademy has worked very hard to curate itself a team of the topmost educators all across India, and now you have a chance to study from any of them from the comfort and safety of your home. So that's a wonderful opportunity which I think all students must try and utilize. So how do you avail these benefits? How do you make sure that you are making the most out of these opportunities? So the starting step is to install the Unacademy app. Now, the moment you do that, you will realize you unlock yourself a lot of free features. So there are free courses which happen on the Unacademy Plus. So you can enroll in those just after installing the Unacademy app. Plus, there are a lot of special classes which are again free for all students. Okay, that any student can join at any time just after installing the app without even having the subscription, so you can attend those. And then of course you can take part in the quizzes that we have every week. So tomorrow we have a quiz on rotational motion, so those of you who are interested to take part in that can again install this app and unlock all these free features using the code RD Live. Okay, so make sure you are downloading the app and getting at least these free features, and you can unlock all those using the code RD Live. Okay, now, when you are satisfied, when you like the things that you see in this free features, and if you finally decide to take the plus subscription for yourself, this is how you can go about that. So first thing is you can go to the plus section of the app, select your goal as IIT and click on that get subscription button. Okay, so that is how easy it is to get the subscription. When you do that, you'll be redirected to the payment page where you will have a box which will say, do you have a code? There you can put this code RD Live and get yourself the Unacademy Plus subscription or the Iconic subscription. So there are two options now of getting the subscriptions. So the Plus subscription is the regular subscription with which you unlock all the benefits of Unacademy Plus. An Iconic subscription gives you even more benefits, which we will tell you. I will tell you about in a bit. So now, if you look at the fees, also the fees of all these subscriptions is very less. So you have a 12-month subscription, which comes to about 2,800 a month. 24-month subscription coming to about 2,100 rupees a month, which is very less compared to the kind of fees that you would have paid in any offline setup. I know students of class 5th and 6th pay double this amount for their home tuitions. Okay, and any reputed coaching institute would charge you at least 4 times to even 10 times this fees. Okay, for the same quality of education that you will be getting here on your Unacademy Plus. As I said, most of the top teachers are all across the nation are there on this platform. So once you have the Plus subscription, you can join anybody's course, not only physics, not only my courses. You have a choice to join anybody's course, okay, that you like, and you can join as many courses that you feel like. Okay, so you can even take 2 courses of physics, 5 courses of physics, 3 courses of chemistry, and so on. So the amount of benefits that you get out of this subscription are unlimited. I think these prices, trying that subscription is a must. It will be, even if you are starting from elsewhere already, this will, if nothing else, be a great support. Okay, this can be your entire guide to your IIT journey. So again, as I said, at the prices that you this subscription is being offered, the benefits are way huge. Okay, to miss out on this. All right, so now you will also realize when you click on proceed to pay, you also have a lot of options to choose from, no cost EMI options. So you don't even have to pay this amount in a one go. You can choose a lot of no cost EMI options according to whatever suits you, so that you're not feeling the pinch of that payment also. Okay, now let's tell you about the iconic subscription then. The iconic subscription is a new feature that Unacademy is offering. Okay, and this will help your IIT JEE preparation it'll take your IIT JEE preparation to the next level. Okay, so how does it do that? You will be allotted personal coaches, so that's something very great. So from a professional team of mentors, you will be guided some personal coaches who will closely and personally monitor your performance, and guide you to your IIT JEE journey throughout. They will guide you which courses to offer, when, how to plan your studies, and everything. So you will also be attending a lot of IIT JEE workshops. You'll be receiving expert guidelines from time to time. You will be getting a study planner and regular test analysis sessions. So these features are mostly meant for students who feel that they want more individual attention. Okay, so if you are that kind of student who wants more individual and personalized guidance, then you should go for the iconic subscription. All right. Now another great thing is that for those of you who don't even have the app, you have a great chance of testing your knowledge, checking your standing amongst your peers, and if you do well, you have a chance to win yourself some really cool prizes by taking part in the next Unacademy Combat. For those of you who don't know this, this is the most competitive gamified IIT battle, okay, that is there online. So you can take part in this, compete live, and the next event is going to be on the 3rd of January. You can enroll now using the code RDLive and do well and win yourself some really cool prizes and gift vouchers, including an entire year-long subscription of the Unacademy Plus, completely free. Okay, so make sure you are competing there. Now there are new batches that are recently launched on the Unacademy. So here is information about that. So you have a Manzil batch, which is for Target 2022. You can enroll now in that. And then you have a Rank Booster batch, which is for Target 2021. So you can enroll in that also. So these are the new courses that have been recently launched on Unacademy. So if anybody wants to join them, can. Okay. Now, those of you who are following us on the JEE English channel of YouTube should connect us with us on the Telegram app using this link, okay, so that you're not missing out on any of the sessions and lectures which are happening here on the JEE English channel of YouTube. Right, so with all that information, now let's get back to our regular studies. Okay, so Shivam says, sir, you remember your promise you did to me about my counseling? Absolutely, Shivam, absolutely. I do. So why don't you do one thing? You are already a plus student, right? So today I have this new course starting on plus at 6:30, right? So you can come there and we will talk about it. Okay? Don't worry about it. Yes, of course. All right. So hello AP, how are you? All right. So, in the last class, we were talking about what gravitational potential is, what potential energy is. Now, today we will talk about its applications. So, once I've learned how to calculate the potentials and the potential energy, all right, then I'll see you there, Shiva. Okay. So, once you have learned how to calculate the potential and the potential energy, we will see the applications. And all right, AP. So, this is one thing that I left in the last class, right? you're trying to derive the expression for the gravitational potential of a solid sphere. So today we'll start our discussion from there. Okay, so let's imagine. So for a solid sphere, again by logic, I can say for any point which lies outside the sphere, I should know the potential. Why? Again, the gravitational field I know would be identical to a point mass kept at the center. So for all points for which r is greater than r, I know the potential. Okay, so I know v at any distance r would be equal to minus g m over r for r greater than r. So this is sorted. How about r less than r? So that is where we need to work on. Okay, so let's imagine you have this solid sphere. Okay, so there is this solid sphere of radius capital R having a total mass m, right? And I have to find the potential at some point which lies inside. So let's imagine there is a point P, and this is at a distance of small r from the center, and this guy has a radius of capital R. So suppose I have to find the gravitational potential at the point P. Then how do I do that? So what I'll do is I will divide this sphere into two parts. Okay, I will one consider this sphere of radius small r, and then so this is my one portion that I'm considering. Okay, one portion is this, and then the second portion is the all the mass that lies outside this sphere. Okay, so imagine that. Second portion, let's say, is this. Okay, so these are the two portions in which I will consider the sphere to be made up of. Now, for the inner portion, I know how to calculate the potential. Why? Because for the inner sphere, the point just lies at the edge, right? So I know for that point P, all the mass of the inner sphere, green sphere, will behave as a point mass kept at the center, right? So I know. So let's call this part one of our mass distribution, and let's call this part two of the mass distribution. So I know the mass, if this has a mass m dash, let's say this has a mass m1 and this has a mass m2. So I know p due to 1, potential at p due to 1. How much will that be? That will be given by this formula. Will be minus g m1 over r, where m1 is the mass enclosed in this, correct? So I also know what is m1. M1 would be equal to total mass into r cube over capital R cube. Okay, how do I get that? It's just density into mass. Okay, so density would have been total mass over 4 by 3 pi r cube, pi capital R cube, into the volume of the smaller sphere, which would have been 4 by 3 pi small r cube. So 4 by 3 pi, 4 by 3 pi would have gotten cancelled, and this is the value of m1 that I would have gotten. Okay, so the potential at P due to the part of the sphere, the green sphere, would be this much. So if I can now calculate the potential due to the outer part, then I'm done. Okay. So now for the outer part, now the trick that I'll use is I will break this into a lot of concentric shells. Okay. So let's imagine I am considering a shell of radius x and thickness dx. Okay, imagine something like this. So I'm considering a shell of radius x and thickness dx. So let's say it has a mass of dm. So I already know this guy would have produced the potential, which would have been the potential at the surface, right? So let's see what this part can produce. So let's call this dv2. dv2 is the potential, small potential created at the point P due to this shell of radius x and thickness dx. So dv2 should have been equal to minus g em over x. I know inside a shell, the shell produces the potential, which is the potential at the surface, correct? Now, if I can integrate this, then I can find out the total potential created by the entire orange part on the point P, right? Now here, what will be dm? I can say dm would be density. So let's just write it in terms of density for now. Okay, so rho times 4 by 3. Okay, so the volume of the shell would be 4 pi x square dx. Okay, that's how you calculate the volume of the shell. Surface area of the shell into its thickness. Okay. So all I need to do is substitute this value. Okay, so if I substitute this value, let's see what we are getting. So I'm getting dv2 equals minus g rho to 4 pi into x square, and bottom I had 1x, so 1x will get cancelled. So I have x dx. Okay. Now the integration limits would be from small r to capital R, correct? That is going to be the range of my x. The small shells that I will consider here. The first shell would have this radius and the final shell would have this radius, correct? So the integration limits of x would be from small r to capital R. Now let's see what that result is. So I'm getting minus, and let's substitute the value of rho also. So rho would be m over 4 by 3 pi capital R cube times 4 pi, and here I will have capital R square minus small r square by 2. Correct. So let's get rid of this. So what I'm getting is v2 equals minus vgm over 2r cube times r square minus small r square. So now that I have calculated the potential due to both the parts, the total potential would be sum of V1 and V2. Great. So V would be equal to V1 plus V2. Let's see how much that comes to. So V1 I already knew was this one. Okay, was this one. So let's just substitute the value of this. It will be minus G. Okay. Right. So it was minus G capital M, and then I would have had R square over R cube. Okay, if I substitute the value of M1, then this is what I'm getting, right? And I have minus 3g capital M over 2r cube times r square minus small r square. Correct? Now let's see what that comes out to be. What I'll do is I will take minus gm over r cube as common. So I can say that v would be, if I take minus g capital M over r cube as common, and so inside I have r square here, and I will have plus 3 by 2 r square minus small r square, right? So what does that come out to? So that will come out to a minus, I will have g capital M over 2r cube, and inside you will realize you will get 3r cube 3r square, and then you will have minus r square. You can see that. Okay. No, that's not the thing. The iPad is pretty new. iPad is new only. It was bought this year. Okay, it's just sometimes it just, I don't know, something happens. I'm not even sure what happens. So this is the expression. Now this is a very, very important result. This is a very, very important result. Okay. So this is the V for all points which lie inside. Please remember this, very, very important, especially for advanced. Advanced people love asking questions from this. Okay. So this is V for all R less than capital R. Okay, that is what this formula is telling you. You must memorize this. Okay. Both in iPad, wo ho sakta hai. Okay. So now if you look at the graph, this is what the graph of the potential looks like. So you realize this, the magnitude of potential is maximum at the center, which is 3 by 2 times the magnitude of the potential at the surface. So I hope you can see that. If this is V surface, this is 1.5 V surface. So that is one way to remember it. These two results are used pretty often. Okay, so remember that and try to memorize this result, because trust me, J advanced people, whenever they ask a question about potential, they will ask the question related to that formula. Okay, so that is their habit. Okay, they love asking that formula. Mains also they may ask, but mains they usually don't. Okay, but in advance they definitely do. If you are getting a question from gravitation on potential, it is going to be with that formula definitely. Okay. All right, so now why don't we start with some practice? Okay, so here is a question which tells you a particle of mass small m is placed at the center of a uniform spherical shell of the same mass and radius capital R. You find the gravitational potential and the gravitational field intensity at a distance r by 2 from the center. So where will I find questions related to this topic in which book? You can try any book. H.C. Verma is there. You can solve your previous year questions. Okay. And plus, in the plus course, I will be giving you DPPs, so don't worry about it. Okay. In the plus course, I will be giving you DPPs, so you don't have to worry about this. All right. Okay. So let's see. Let's see. Why don't you guys try this? Okay. Let's see. Let's see if you can figure this out. This is easy only. Okay. You should remember that both gravitational field intensity and the gravitational potential both follow principle of superposition. Okay. You can use those and find the answer for this. Okay. Let's see if you can quickly figure this out. So we are starting with a basic level question only. This is a very easy question. Okay. This, I think it's a mains level question. This may even be asked in your school examinations. Okay. Board level kind also. All right. Let's see. Let's see if you can figure this out. Come on. Let's quickly answer this so that we can move ahead and start our discussion with escape velocity. That is another interesting thing. Okay. Hint, just use superposition principle. Okay, so that's my hint to you. Simply use the superposition principle and you'll be sorted. Okay. All right. Is anyone even trying? Let me know. Okay. Tried but no result. Okay, that is strange. Okay, this is very simple. Let's tell you. So here is a shell. Here is a shell. Right. This has mass m, and this has some radius capital R. And you've been told you have also placed another point mass m here. Right. So if you have a point here, you have a point here which is at a distance of r by 2. Okay. So let's try finding the potential at P due to the shell. So I can say at P, the potential due to the shell. कितना होगा भाई? भाई शेल की वजह से ओके ओके आई थिंक ओके तो लेट्स सी शेल की वजह से कितना पोटेंशियल आता शेल की वजह से आता जो सरफेस पे आता है माइनस जी एम ओवर आर अग्रीड शिवम ध्यान से देखो शेल की क्या प्रॉपर्टी होती है शेल क्रिएट्स अ पोटेंशियल व्हिच इज इक्वल टू द पोटेंशियल एट द सरफेस एट ऑल पॉइंट्स इनसाइड so this would have been the potential that would have been created by the shell. And how about the potential due to small m? potential due to small m, जो सेंटर पे रखा है, उसकी वजह से क्या आता है, माइनस जी एम ओवर आर, एंड आर वुड हैव बीन आर बाय 2, राइट. सो क्या आएगा, आपका रिजल्ट आएगा V net would be equal to the sum of these two potentials minus 3 gm by r. ये आएगा पोटेंशियल, माइनस 3 gm by r आ जाएगा नेट पोटेंशियल. ओके. सिमिलरली हाउ अबाउट द ग्रेविटेशनल फील्ड इंटेंसिटी. इंटेंसिटी के लिए शेल की वजह से जीरो होगा, ड्यू टू शेल इट इज जीरो, ड्यू टू पॉइंट मास विल बी माइनस जी एम ओवर आर बाय 2 होल स्क्वायर. ओके. तो आपका आ जाएगा माइनस 4 जी एम ओवर आर स्क्वायर, आर कैप. ये आपका ग्रेविटेशनल फील्ड इंटेंसिटी आ जाएगा, है ना. सिंपल है, डोंट वरी, आप इतना घबराओ मत, इतना घबराओ मत. मैंने आपको बोला, यू जस्ट ऑल यू नीड टू डू इज यूज द रिजल्ट ऑफ सुपरपोजिशन. So you know both the individual results, just add them together. That's about it. Okay. Now, let me tell you a bit about the relation between the gravitational potential and gravitational field. This is very interesting. Again, since you know any conservative force is related to its potential energy function like this, right? I have taught you this in the work energy power class. Correct. Now I can, if I divide, I can write this as I vector times m. Okay, if a mass m is kept at a point and the field intensity there is I, so what is the force? Force will be gravitational field intensity into mass. And what will be the potential energy? Potential energy would be del by del x of v times m, right? Potential energy per unit mass is m. So potential energy of mass, point mass kept, m kept at that point would be this. Okay, agreed. कैसा आ जाता है? Okay जी. अब m तो कांस्टेंट है, so since m is constant, I can cancel out all the m's. And the relation I have is I vector is equal to minus del v over del x, I cap minus del v over del y, j cap minus del v over del z, k cap, where represents the del represents the partial derivative. Okay, I hope everybody knows what partial derivative is. Hello, bloody Joker. Wow, that's a scary nickname. That's a very scary nickname. Okay. So this is your final result. You should remember that. Okay. There are sometimes questions asked on this also. Okay. So I hope everybody knows what del operator is. है ना? Del पता है ना सबको? Del v by del x is partial derivative of v with respect to x, and so on. All right, great. So now let's try and answer a few questions based on that. So here you've been told that the gravitational potential in any xy plane varies with x and y as v equals x square y plus 2xy. Find the expression for gravitational field strength I. Okay, so this should be super easy. Okay, let's see. You have been given v in any xy plane as a function of its x and y coordinates. Can you find the expression for the gravitational field intensity? So just use this relationship and that is it. You will be sorted. Okay. Let's see. Okay, this should be super easy. Hmm. Okay, I think you guys may have a tough time just writing the expression. So let's just solve it. So we know the expression for v. V is given to us as x square y plus 2xy, right? Yep. So I can say that my del v by del x, that is partial derivative of v with respect to x. Yes, yes. Oh. अरे नहीं, ये कितना हुआ? 2xy प्लस 2y, है ना? और डेल वी बाय डेल वाई कितना हुआ? तो डेल वी बाय डेल एक्स आया। डेल वी बाय डेल वाई कितना आया? वो आया एक्स स्क्वायर प्लस 2x। तो आई कितना हो जाएगा? आई वुड बी इक्वल टू माइनस डेल वी ओवर डेल एक्स आई कैप माइनस डेल वी ओवर डेल वाई जे कैप। हाँ, सो कितना आएगा? ये आएगा 2x एक्स वाई प्लस 2y with a minus sign I cap and plus x square plus 2x j cap। ये आएगा एक्सप्रेशन। हाँ, the minus sign of course। ठीक है, आधा मिस कर गए आप, आधा मिस करके। You have to differentiate the entire expression, not just a part of the expression, okay शिवम? पूरा एक्सप्रेशन को आप डिफरेंशिएट करोगे ना x के रिस्पेक्ट में एंड y के रिस्पेक्ट में। So that's the point. You need to differentiate the entire expression of v with respect to x with respect to y. Okay, got it? Now this is simple only. All right, now let's move our attention to satellite motion and escape velocity. So first of all, let me tell you something called binding energy. So what is binding energy? So you will realize if any object is bound in a gravitational field, okay, that's all right. That's all right. So work on that, and you know where the problem lies. Okay. So work on that. Remember your basics. So revise your basics and keep practicing daily. So dedicate 1 hour, just 1 hour daily to this. In 15 minutes, you revise your key ideas of any topic, and then 45 minutes just practice. Just solve 5-6 questions daily. Keep doing that, and trust me, you will get used to it. Okay, and then you won't have these problems. All right. So as I said, binding energy. So if any object is bound in the gravitational field of Earth, then the total mechanical energy of the object is of the object and Earth system is always negative. Now the modulus of this mechanical energy is called the binding energy of the system. Now, what do I mean by binding energy? Binding energy is the energy which is keeping this some object bound to the gravitational field of Earth or maybe any other substance for that matter. So you realize if you have Earth and if you have an object here, so this system may have some energy. It may have some energy if the object is bound. If the object is bound, what does that mean? That means it cannot escape this gravitational field. So it will either keep on rotating or revolving around the Earth, or maybe fall on Earth, or do whatever. So the idea is it cannot escape the gravitational field of Earth. Now, if it were to escape, imagine if it were to escape, if this object could actually reach infinity. So if this could reach infinity, then what is the total energy that it would have had? Okay. So first, at infinity, u would have been 0 for the system, and the k min is 0. And a minimum kinetic energy that it can have is 0. Otherwise, kinetic energy is always positive. So you realize, what you realize is if two masses are separated by infinite distance, then the minimum energy of the system is 0. Minimum total mechanical energy of the system is 0. Okay, in such a case. Now, what you realize is if something is bound to a gravitational field, then the total energy would be always negative, because being bound to a gravitational field implies that this guy cannot reach infinity. If it cannot reach infinity, then it has to have energy lesser than the minimum energy required to reach infinity. So at infinity, the total mechanical energy minimum is 0. So if it cannot get there, so it must not have zero energy also, which means that its total energy, mechanical energy would be negative. Why negative? Because potential energy is negative and kinetic energy is positive. So the potential energy numerically should be higher than the kinetic energy. So if that's the case, then you can say that this object is bound to that gravitational field. Okay. Now you realize the modulus of this total energy is known as binding energy. Why? So suppose this is a system here and this has some energy of minus E, total mechanical energy of minus E. So if I can give this system plus E amount of energy, so its total energy would become zero, and that is the one which is required to escape the gravitational field. So to escape the gravitational field, any system must have minimum of total zero mechanical energy. So if at any stage the system has minus E mechanical energy, then you can provide it plus E mechanical energy to make it zero, right? So that is why that mod of the total mechanical energy is known as the binding energy. This is the energy that you require to give to the system to free it from that gravitational boundation. Okay. Now this is the energy required to separate an object from the earth completely, or making them infinitely away from each other. Okay, so that should be easy to see. All right. So now let's talk about the escape velocity. So if any particle is kept on the surface of the earth and given a kinetic energy which is equal to its binding energy, then it will be able to escape Earth's gravitation completely. Okay. Sir, why center of earth is not assumed zero? There also force is zero. Okay, so I don't understand what you're saying. I don't understand what you're saying. Why center of earth is not assumed zero? Matlab? Oh, for gravitational potential. See, potential is not about the force. Potential is about the energy. And the potential at the center of the earth will not be zero. Remember this. At the center of a sphere, you have a negative potential. है ना? तो potential zero नहीं है. Okay. We are talking about energy, not force. Okay, so the energy at the center of the earth is actually rather negative. Zero कब होगा? Zero infinity पे ही होगा. Okay. All right. And that also, but the earth center is a single point, which may have potential if other masses are also there. But no matter how many masses are there, at infinity, all their force would reduce to zero. Okay. The net force can only be zero at infinity. Okay. So what I am trying to say is, let's talk about an object which is placed at the surface of the earth. So imagine this is the surface of the earth, and let's imagine there is an object kept here, है ना? यहाँ पे रुका हुआ है object. So let's see what is the total energy that it has. So initially, if it is at rest, it will have a negative potential energy, and potential energy of my system would be, let's write it like this: U would be minus G times mass of earth, mass of object over radius of earth. Right? R is the radius of earth, M is the mass of earth, and small m is the mass of the object. So this will be the total potential energy. Now, what kind of energy do I need to give this so that it can escape to infinity? I know if I have to give it some velocity v, so let's say, let us give this object a speed v. So how much should v be so that it can escape to infinity? Okay, I know for the object to reach infinity, total mechanical energy should be equal to zero. Okay, by energy conservation. This, as it moves away from Earth, its kinetic energy would get converted into potential energy. Kinetic energy would reduce and potential energy would increase. The potential energy can increase up to zero at infinity. So if all the kinetic energy in converting into the potential energy can just make the potential energy zero, then this guy can just reach infinity. Imagine when it is moving away, its potential energy is increasing, kinetic is decreasing. And suppose if here only all the kinetic can get converted into potential, then it will come back. Just like you have something in vertical motion under gravity, है ना? When you throw something up, there is a maximum height to which it can go. The maximum height is determined as the point where all the kinetic gets converted into its potential. Now, if I had to find how much u should be given so that by the time all the potential energy gets converted, all the kinetic gets converted into potential, it can reach infinity. अगर infinite height तक पहुंचाना है, so I can say total mechanical energy should be zero. Okay, so I can say half mv square. Therefore, half mv square should be equal to my plus g m over r. Okay, so that is where you get this formula. This one, that v should be equal to 2gm over capital R. If you give this much speed to any object kept at the surface of the earth, then it can reach infinite height, or it can completely escape the gravitational field of earth. Now you can do one more thing. You can multiply and divide this with radius of earth. So if you multiply and divide this with radius of earth, then what you realize is that this term is g, which is acceleration due to gravity. So it can also be written as root 2 gr. Again, this is another important form of the equation which you can remember. The escape velocity is equal to root 2 gr, very commonly used result. Okay, remember this. Now for Earth, turns out this speed comes out to be 11.2 kilometers per second. So if you can throw some object, with an initial speed of 11.2 kilometer per second, then it will be able to escape the Earth's gravitational field completely, and it will be able to reach at an infinite distance from Earth. So hello Mahi, how are you? Hi Rajesh, hello Raj. So how is everyone? Okay. Now turns out this definition is not only restricted to Earth. Okay, you could have applied this for any kind of planet. So for any planet, you can say for any planet or any celestial object. So escape velocity would be root of 2g times mass of that object over radius of that object. You can find the escape velocity at sun also. Okay, when you have to find the escape velocity at the surface of the sun, all you need to do is put m as the mass of sun and radius as the radius of sun. Okay, now you can calculate that for any planet. You can calculate now the escape velocities at the surface of Jupiter, Saturn, anything that you feel like, any hypothetical planet also. Like in this question. This question says that a planet has a mass which is 9 times the mass of Earth and radius which is 3 times the radius of Earth. You have to find out the escape velocity at the surface of that planet, given that the escape velocity on Earth's surface is 11.2 kilometer per second. Okay, so try this. Let's see if you can get this right. Okay. So this is easy. Just use this formula. Just use this simple formula, and that'll be it. Okay. So let's see some answers quickly. So your imaginary planet has a mass which is 9 times the mass of Earth, and radius is 3 times the radius of Earth. So what will be the escape velocity at that planet? Okay, that is what you have to find. Okay. अरे नहीं 3 टाइम्स क्यों कर रहे हो? 3 टाइम्स क्यों कर रहे हो? फिर से देखो, फॉर्मूला सही लगाओ. ध्यान दो. Be a little careful, Shivam. ये गलती करते हो. So don't be in a hurry. Look at the formula. And then try and figure out. No, it won't be 3 times. No. Yes. No. फिर से गड़बड़. हाँ, root of this, right. हाँ, नहीं. अभी भी गड़बड़ है. अभी भी गड़बड़ कर रहे हो. देखो, see, we escape for planet. DE for planet would be a root of like mass of planet over radius of planet. Correct. Similarly, V escape for Earth would be equal to root of 2g mass of Earth over radius of Earth. Correct. Hmm. एक मिनट यार. Okay. Just a second. Yes, yes, yes. AP is absolutely right. That is the correct answer. Exactly, Shivam. 11.2 root 3 ही आएगा, obviously. Why not? I think you are just in a hurry and making silly mistakes. So I think most of the times this is what you must be doing in your questions also. And then feeling bad that you're not able to solve. I think you are just making small, silly mistakes. Don't do that. So from here I can say this is root 3 times escape velocity of Earth. So that is root 3 times 11.2, which is 1.7 times this. So yes. No, no, of course not. No problem, no problem. Just be a little careful. हाँ ठीक है. That's all right. That's all right. That's all right. कोई दिक्कत नहीं है भाई. Just be confident. Just be confident. Roughly around 19.4 kilometer per second. Very well done. Okay. Now let's talk about something very interesting. Now let's talk about a black hole. What exactly is a black hole? Eh? So when any celestial object is so massive and dense that the escape velocity at the surface of the object becomes more even than the speed of light, then even light cannot escape that celestial object, right? And this kind of celestial object is what we call black hole. Now, nothing can escape from them as they have not, so they cannot be seen by any means, and that is why very less information is known about black holes, and they are very hot topic of research. All the research done by Hawking was about black holes, right? Infinite mass concentrated in a small space. So not really infinite nahi hota. Black holes have finite masses. Black holes have finite masses. Their density might be infinite, and that too we don't know. We don't know much. It's only our estimate. It's only our estimate. Okay, we believe that there would be a point of singularity that we say at the center of the black hole. Okay, again, this is all just theory part. But essentially, what the idea is, if you remember this expression of escape velocity is root gm over r, right? So you realize this expression, depending on the value of m and r, can give return a escape velocity, which might be greater than c, right? So if ever this escape velocity becomes greater than c, then that thing will behave as a black hole. Why? Because even light cannot escape that. Okay. So that is what a black hole is. Black hole is something which has such a high gravitational field that even light cannot escape it. That is why it appears black. It appears black. So any light. So how do you see objects? How do you see objects? How do you see stars? So the reason why you are seeing stars is that light from these stars is reaching you. Right? Suppose here is our Earth. So light from this star is reaching you. So you can see this star. How do you see the moon or other planets? So you know that light coming from this star may get incident on this planet or moon, and from here it reflected light will reach you. So you will see this object. Correct. That is how we see things. Yes, yes, absolutely. Right. So our the only reason why we can see things is that if light falls on them and it reflects back. Now, what happens to this black hole? Now, with this black hole, the problem is that any light that reaches this region will disappear. It won't ever come out because of the high gravitational field. So that is why, since there is no light coming out of here, you don't see anything. You see the entire space as black. Okay, so how do you know? How do you know that there is something even there? How did we get an idea? How is it different from any other blank space? Okay, where does the energy go? So there are a lot of theories. Okay, so Hawking said that the black holes do emit some kind of radiations called Hawking radiations eventually. Okay, but again, those are still theories, and we don't know much about black holes. So there are still a lot of research going on. Okay, so we will probably law of conservation of energy not obeyed. No, in fact, we don't know. We are not sure what exactly happens inside the black hole. As I said, the center of the black hole, people have suggested, acts as a singularity point. You know what a singularity is in mathematics? In mathematics, a singularity is a point where a mathematical function cannot be defined. Function cannot be defined. That's a singularity. So we believe at the center of the black hole, there is a singularity point where physics can't be defined. So we don't know if normal laws of physics work there or not. We assume that normal laws of physics will not work there. Okay. So at the singularity, we believe that the normal laws of physics probably will not work. Okay. Two parallel dimension. Okay, again, these are all theories. Nobody has been inside a black hole, no. So we can't be sure. We can't be sure. There are a different lot of theories. Okay, two parallel dimensions. We believe that space and time get merged there. Okay, at that singularity point. Okay, so we can't be sure. We can't be sure of anything. But what we know for sure is that light cannot escape this. Light cannot escape this. We do not know what exactly is happening. So there are a lot of theories, but we don't know conclusively that what exactly is happening inside the black hole. I'll go one day for summer trip. No, please. No, you have no idea how high the gravitational field is. The gravitational field is so high that it will shred you into atoms. It will shred atoms also. This is again an estimate. Again an estimate. So if you enter this region, turns out the gravitational field is so high that imagine, the gravitational field varies with height, right? Acceleration due to gravity varies with height. So it turns out in a black hole, the variation is so high that at the bottom, the G would be so high than the G at the top that everything will get stretched. It will shred. It will break. Everything will break. Everything, even electrons, will be ripped apart. Okay, because of the high gravitational forces. So let's not plan a trip to a black hole ever. Okay. Anyhow. Now the idea is you realize here that the escape velocity at the surface is given like this. What do you think will happen if I release any object from a certain height? If you release any object from a certain height, then what do you think will happen? Okay, then the escape velocity would be lesser. Okay, so this is giving me a problem again. Okay, I don't know what is wrong with the software. Okay, let's see. Yeah, this is better now. Tamam, ekdam. Okay. So what happens is at the surface of Earth there is a certain escape velocity. What will happen if you move to a height? If you move to a height, what do you think will happen to the escape velocity? At a height h, if you are here at a height h above the surface. What you realize is that here the escape velocity would be less than the escape velocity at the surface. Why? Why? Your potential energy is minus gm over r plus h. So you realize the negative potential energy is already reducing as you are going higher and higher. Since the negative potential energy is reducing, now you need lesser energy to be given it to the object, right? नहीं नहीं उसकी जरूरत नहीं है, वो ब्रॉडकास्टिंग सॉफ्टवेयर की दिक्कत है. Okay, what happens is as you move higher and higher from the surface, the required escape velocity reduces. Okay, the required escape velocity reduces. Where do you think will the escape velocity be the highest? Okay, so please note this. This is very, very important. As you move above the surface, the escape velocity decreases. Okay, I hope the logic of that is clear. Why? The gravitational potential energy is decreasing. The negative energy is decreasing, so the positive amount of energy that I need to give it to you, give it to also reduces. So escape velocity required reduces with height of the surface, with height from the surface. Correct. What do you think will happen if I go into the depth? What will happen if I go into the depth? Hello, Shivans. I am good. So yes, yes, yes. Shivam is absolutely right. Escape velocity would be highest at the center. If you notice this again, सबका logic यही है. If you notice this expression, the potential and hence the potential energy is going on reducing. Okay. Yeah, I know, I know. I know. यानी बार बार क्यों दिक्कत दे रहा है? Okay. No, no, it's just easier to write on the iPad with the pen. So that is why I prefer this. Okay. Now are things visible? Okay. Yeah, this should be better. So as I was saying, the entire logic of everything is by this graph. Okay. If you look at this graph, what is happening to the potential? The potential and hence the potential energy in the negative sense is highest here at the center of a sphere. And as you move away from the sphere, the negative potential energy is decreasing. So you realize the amount of positive energy that you need to give also decreases. Or can I say that the binding energy is decreasing as I'm moving away from the center of the of any mass. Okay. So that is why the escape velocity would always be highest at the center and would be lowest again at infinity itself. Then you don't need to give it any velocity, right? So that's the entire idea. In fact, IIT JEE Advanced had asked a question on this. They had asked that if something is launched from the bottom of a crater in moon, they said imagine there is a small crater in the moon, and if something is launched from here at the bottom of the crater with the escape velocity at the surface, with the escape velocity of surface, then what will be the maximum height? Turns out this will not reach infinity because the moment you are below the surface, the escape velocity would be higher. Okay. So and I can say, so if I add to this, I can say also, so it increases as we go below the surface. Okay, so that is something very, very interesting. Yes, it will stop before infinity. Okay, so definitely. So this is what the question was based on. They created a crater and उसके bottom से उन्होंने release किया था. Now what happens is, so it will come back. It will fall back eventually. Now what happens is that I don't know what is there. What is there? So let's assume hypothetically that in a very small space, that is what we believe. In a very small space, all the mass of the black hole is concentrated. Now you realize as I move away from this, the escape velocity is reducing, right? So here, if escape velocity here is, let's imagine escape velocity here is greater than c, so it will reduce, and eventually at some distance, the escape velocity will become equal to c. Correct? At some distance after reducing, the escape velocity will become equal to c. So what you will realize is that for this entire region, the escape velocity would be greater than c. Correct? For this entire region, the escape velocity would be greater than c. So that is something very, very interesting. Okay, for all the black region. Yes, that is the logic. That is the logic. See, okay. So let's see. Think about this. Think about this. है ना? अगर आप यहाँ पर हो और सेंटर से r डिस्टेंस पर हो, सेंटर से r डिस्टेंस पर हो, let's assume. Okay. So what will be your escape velocity at a distance r from the center? So you will realize escape velocity would be root of gm over r. Okay, I hope you realize that. ठीक है, ये होगा. So you realize at a distance r, एक ही escape velocity होगा पूरे r में. That is why black holes appear circular. That is the reason why they appear circular to you. Okay. Because for an entire range of r, the escape velocity is same. So if at a certain distance, okay, again, क्या हो रहा है बार बार? Okay, so if at a certain distance your escape velocity reduces to c, then you realize at the same distance everywhere the escape velocity would be equal to c, right? For this entire range, the escape velocity would be less than c. So what that means is if anything enters this entire spherical region, so there will be a sphere, and for that entire spherical region, inside that the escape velocity would be greater than c, right? So if anything ever enters this entire region, then that cannot ever escape. Light can never escape the moment it enters this region. Okay, that is why you see spheres as black holes. Okay, okay, sure, I will. And that is the reason why you see this entire region as black. Okay, now the boundary of this is called event horizon. This is called event horizon, the boundary of the region beyond which the escape velocity starts becoming greater than c is called event horizon. So anything beyond event horizon can never be seen. Okay, so if anybody has seen Interstellar, then you would have heard that term. In Interstellar, they say we are about to enter the event horizon. Okay, so that is the idea of event horizon. Now we will try and talk about calculating the radius of theory for boards. No, not really, but it can come as a numerical for your mains and advanced. वो तो बस ऐसे ही ज्ञान है. GK. Event horizon is just GK. So you can now even calculate the radius of event horizon. Okay. All right. Yeah. Don't worry. You will get enough time later in life to watch all these things. Okay. Yeah. I figured that. I figured. So that's a very wise choice, and it requires a lot of control. So well done. Kudos to you. अभी time है नहीं. अभी just focus on the lectures only. Okay, later you will have all the time in the world to watch all those movies and stuff. So let's imagine if the radius of this. Let's imagine if the radius of this event horizon is r. Then I know at the boundary of this event horizon, the escape velocity should be c, and we already know at a distance r what is the escape velocity, since we know v equals root gm over r times. Would you realize at small r and at small r equals capital R, v equal to c. This we know. At the boundary of the event horizon, escape velocity is c. So what you realize is that c square equals 2gm over r. So if you know the radius of the event horizon, you can actually estimate the mass of the black hole. Okay, so that is something very, very interesting. We don't know much about black holes, but we know masses of black holes that we have observed. So that is very, very interesting. Using simple Newton's law equations, now you can tell the masses of black holes, okay, without being able to see them also. That's another very, very interesting uh, numerical that can be asked of you. Okay, so if by parallax method they can say the radius of a black hole was estimated to be this, then find the mass of the black hole. You can estimate the mass of the black hole. Okay, that's very interesting. And again, as I said, a numerical based on this can be asked very easily. Okay, now this is a question that has been asked in mains. Okay, there they have asked, find out the maximum radius up to which the earth must shrink in order to become a black hole. No, not one marker, but a proper mains question. Proper mains question. This is a proper mains question. This is a previous year mains question. In mains, they have asked this question. Okay. So if I were to shrink the earth, you have to find the radius to which it should be shrunk so that the earth starts to behave as the black hole. Okay. So when do we call anything a black hole? If the escape velocity at the surface at least should become greater than c or equal to c. So you can figure this out quickly. Okay, let's try and quickly do this. I know c should be equal to square should be equal to c square should be equal to 2g m over r. So from here I will get r. R should be equal to 2 into g. G is 6.67 into 10 to the power minus 11. Right, mass of earth is 6 into 10 to the power 24 over c square. C square is 9 into 10 to the power 16. Correct. Now when you do this, you will realize r is roughly comes out to be 4.4 mm. I think if I remember the answer correctly. Otherwise let's just solve this. Okay, so that is what it comes out to, interestingly. So if you could shrink the entire Earth's mass into a small radius of this, so 2 into 6.67 into 6 over 9. Okay. So now that is slightly strange. गड़बड़ किया क्या हमने? नहीं, I think it's fine. Okay, so I think the radius is actually coming out to be double of this. Okay, so 8.9 mm, something like that. That is what the radius needs to be. Of course, you won't be able to live in any case if Earth turned into a black hole. You realize with that kind of gravity, your body, your bones will not be able to, you won't be able to stand also. With that kind of gravitational force, you would have just become flat. Okay. Your bones would have broken just due to the force of gravity. You won't be able to live, Shivam. So thank your stars that that is not the case. Okay. So anyhow, this is how that is solved. So this is a standard question that has been asked in mains, and this is related to the topic of black holes. All right, so that is where I would like to wrap up today's session then. Okay, I think we have had a lot of interesting discussion today. All right, so this is where I would like to wrap it up. And again, today I don't know why I'm facing these many issues. Broadcasting software, it doesn't happen. Anyhow, time to take a leave. Could you write in board? So I try to write here on this iPad. So the idea is that with the help of this, I can give you PPTs also. No, all right. So that is my time for today, guys, and that is where I will have to wrap it up. And before I leave you, let me remind you that if you haven't gotten your Plus subscriptions and if you're planning to, this is how you do it. Go to the Plus section of the app. Okay, select your goal as IIT JEE and click on the Get Subscription button. Now, when redirected to the payment page, do not forget to use this code RDLive while getting your subscriptions. This will give you a 10% off on all your subscription fees. And now you can choose from two kinds of subscriptions, Plus and Iconic. And you can also choose a no-cost EMI plan for making those payments, whichever suits you. All right. The Iconic subscription is a new offering by Unacademy, which will take your IIT JEE preparation to the next level by allotting you personal coaches and giving you all these extra benefits. Okay. Now, you can also win yourself the Unacademy subscription by taking part in the next Unacademy Combat event, which will be happening live on the 3rd of January. You can enroll now using the code RDLive and then do well there and win yourself really cool prizes and your subscriptions. Another important announcement. So, two new batches have started on Academy Plus. Manzil batch for Target 2022 and Rank Booster batch for Target 2021. You can enroll now and crack your JEE. Now, if you like today's session, then don't forget to use Windows laptop on Academy. Say, okay, I will. Maybe. Again. So if you like today's discussion, then don't forget to press the like button and don't forget to share this video with as many people as you can, so that more and more people can benefit out of this free quality content being given out by Unacademy. If you're new to the channel, don't forget to subscribe to the channel and don't forget to press the bell icon. Now, the PDF of all the slides used in today's lecture would be available for download very soon. And those of you who are following us on the JEE English channel can connect with us on the Telegram app by using this link. Okay. So that ensures that you will keep receiving all the notifications and timely, all the notices about everything that is going on here on this channel. Now, before I leave you, let me remind you, this is my code RDLive. So use this code and you can get a 10% off on your next Unacademy subscription. Now we will carry forward with our discussion of the day after tomorrow. Okay, so you guys can join me. Till then, you go over today's discussions and make sure you followed everything. All right. So you guys keep practicing hard and keep studying hard. And I'll see you day after tomorrow. Till then, you guys